Yeah, we are back. So here in the previous class, I discussed with you about activity number 4. That is here simply reaction of acids with the metal hydrogen carbonates or metal carbonates. In that, we noticed simply what are the products are obtained here. They are here simply gas liberated, salt is formed, and water formed. So generalized equations written for this reaction is followed here. They are here metal carbonate with acid or metal hydrogen carbonate with acid producing salt, water, and liberating the gas called carbon dioxide. How do we tested that carbon dioxide? Using the burning matchstick or using the lime water. So with the both we got a result, right? One is put off and the other is changing milky white color, turns milky white color. So from that we can conclude that liberated gas is carbon dioxide. Now the reaction we are observing between a strong acid and the stronger base. Strong acid and the stronger base. What that reaction is named as? What that reaction is named as here? Simply that reaction we can call it as neutralization reaction. Why do we call that particular reaction only neutralization reaction? So I'll tell you. So what is reaction of acid with the base? What is reaction of acid with the base? So for this we need two substances. One is acid and the other is base. So here simply our aim is to understand about reaction of acid with the base. Then what the materials are required here? You are required NaOH solution as base here. NaOH solution as base here. Then you required here simply HCl as acid. Hydrochloric acid solution. Hydrochloric acid solution. The next you required here phenolphthalein indicator to test the nature of the substance. Your reactant isolize the product. Reactant isolize the product. Then here you are required a delivery tube or a boiling tube. Sorry, a boiling tube or the test tube. You are required boiling tube or the test tube. Along with that, you are required a dropper to transfer the acid or the base into the test tube, boiling tube. Then you need test tube holder. You need a test tube holder. So these are the required materials. So what to do with this? So let us start the procedure here with that materials. So all the required materials are collected here. The next, hold the test tube using test tube holder. So test tube, hold it with the test tube holder as you see on the screen. So holding the test tube with test tube holder. Then take acid or the base into the boiling tube. So first of all, I'm going to take NaOH solution into the boiling tube. So using the dropper, you can fill that with NaOH solution. So first of all, I'm taking NaOH solution, then adding 2 drops of phenolphthalein indicator into the NaOH solution. Then observe what happens. Slowly that solution changes into the pink color. So as we learned in the activity 1, base with phenolphthalein, right? Phenolphthalein into the NaOH solution. NaOH solution. Here it is. Here it is. Simply gives you pink color. Gives you pink color. So that you noticed in the boiling tube. The solution changed into the pink color. What solution? Pink color solution. Sorry, NaOH solution. NaOH solution. NaOH solution. It is simply giving you pink color because it is so here this video is given as Zoom Praveen's meeting, Zoom meeting, right? Praveen's Zoom meeting that you can observe as the video on my YouTube channel. Okay, so here we added NaOH solution, then phenolphthalein indicated to it. Phenolphthalein indicated to it. Then we noticed here that NaOH solution changed into simply pink color. Then I am adding simply acid dropwise. Add dropwise. What? HCl. So slowly 1 drop, 2 drops, continue. Add up to what time? So when the color of phenolphthalein vanishes in the NaOH solution, stop adding up HCl. So first you are taken NaOH. Remember that order. NaOH. Then added indicator. After that, dropwise HCl. Then observe again that pink color vanished. So this is the order we followed. So first we added, again I will show you here, going back. Look at this. So empty test tube is taken, holding the test tube with the test tube holder, adding with the dropper NaOH solution. So up to some extent you can add, then stop addition of NaOH solution. After that, add indicator, phenolphthalein indicator, 1 or 2 drops, 1 drop, 2 drop, then stop. Then observe what happens. That NaOH solution slowly changes into pink color. Base in the presence of phenolphthalein gives you pink color. Then adding HCl solution slowly into the pink color solution of this test tube. So add HCl dropwise slowly up to that vanish of pink color in it. Then stop adding of HCl. Then find the nature of this one. So here simply use red litmus or blue litmus paper. What do you observe? Keep it in your mind. Then also we know phenolphthalein indicator behavior. Phenolphthalein indicator behavior in the presence of base, pink color. In the presence of base, pink color. In a acidic medium or in the basic medium, both in acid or in the base, remains colorless. Remains what? Colorless. So here we know that addition of HCl into the NaOH dropwise, then observing the pink color. So here slowly adding drop by drop, observing the pink color. So when it stops, when it completely vanish, that pink color vanishes in the boiling tube, immediately you are stopping the addition of HCl. No extra drop added to that. Give some gap, 2-3 seconds gap. Observe. Then stop immediately. So that solution nature, if you test with red or blue litmus paper, then you will notice that simply here that a litmus solution is simply gives you observation here as neutral. Then can you change this neutral nature into basic again? Simple. I can add 1 drop of or 2 drops of NaOH again. So add 1 or 2 drops of NaOH, then observe what happens. Again, it starts reappearing in pink color. I added 2 drops of NaOH solution into the colorless solution obtained by adding of sodium hydroxide solution, phenolphthalein and HCl, the three together, giving you colorless solution. Again, I added 2 drops of NaOH solution. Then what I have noticed? Reappeared in pink color. So from this observation, what I am able to generalize here? Simply, I can generalize the reaction between the sodium hydroxide solution and HCl, giving you aqueous solution of a salt. So here, how do you write the equation? If you are in confusion, just break them. So combination of Na and Cl, then combination of these hydrogen and OH will together give you NaCl and H2O. This is the logic to write the equation actually, but that substances we have to observe by the reaction. So salt and water. These are the products. So here, by the reaction of an acid and the base, the products are obtained here, NaCl and water. So here simply, what is the nature of NaCl? Neutral. NaCl nature is neutral. So here simply, what the substances you are taken here? The substances you are taken, acid and a base. Then here you are taken, you are observed the products as here simply a salt, which is observed as neutral. Testing, not deciding directly. So here by the acid and base reaction, you are observing the product neutral. So simply acid base reaction producing the neutral substance. So that's why this reaction is called a neutralization reaction. Actually, that symbol is used wrong here. No symbol here. Okay. So simply I noticed neutral substance is produced by the reaction of base and the acid. So from this, we can write the generalized equation. Simply base and the acid. What is producing here? Commonly a salt and the water. So only from the one reaction, how you can generalize. So to observe about this one, I can conduct many activities using acid and the base. So simply from them, I am generalizing salt and water are the common products by the reaction of acid and base. Right? So to understand about this one, base and acid or acid and the base togetherly producing salt and water. So that can be generalized as here neutralization reaction. So later on we can generalize that So first of all, we are going to observe about the reaction between acid with the metal oxide. Acid with the metal oxide. So what is that metal oxide nature actually? What is the metal oxide nature? Is metal oxides are basic. For example, in the lesson number 2, you learned about the reaction of CaO and water. So you can take distilled water there. You can take distilled water. So here simply that water and quicklime giving you lime water, that nature tested by you using red litmus paper changes into blue color. So indicating the nature of the substance is basic. So that's why here I am saying metal oxides are basic in nature. So that basic substance with acid, so it is similar to activity number 5. It is almost similar to activity number 5. So here just you are observing this acid with the metal oxide and also bases with the non-metal oxides. Simple. Non-metal oxides example, suppose carbon dioxide, sulfur dioxide, right? So this carbon dioxide nature is acidic. Carbon dioxide nature is acidic. So this is what non-metal substance, non-metal oxide. So non-metal oxides are acidic in nature. Metal oxides are basic in nature. So here simply these reactions similar, acid and base reaction. Here base and acid reaction. So commonly it is similar to activity number 5. That is similar to activity number 5 here. So now look at that reactions now you are observing. For this, commonly I am writing the aim of the activity to observe the reaction of acid with metal oxide or non-metal oxides with bases. Okay, non-metal oxides with bases. Okay, so these are the reactions now we are going to observe. So now collect the required materials. So you can write the precautions. So just imagine what maybe happens by combining the acid and the base. As hypothesis, you can write everything. Directly I am going for the required materials to the procedure. Okay, so required materials. Ice here, required materials, metal oxide. You can take calcium oxide, no problem. I'll take here copper oxide. And next, acid. Beakers. Next, required materials are here, glass rod to stir it. Sometimes you need to stir them. So here, simply carbon dioxide gas, lime water. Okay, then here you are going to take procedure, right, with these materials. So why carbon dioxide gas, sir? Non-metal oxide. Lime water, sir? It is base, right? So here, as a base, I am using here lime water. As an acid, what acid? Non-metal oxide. Non-metal oxide. I am taking here carbon dioxide gas. Next, here acid directly taken. Copper oxide is a metal oxide base. Right? So here metal oxide is used as base. Non-metal oxide is used as acid here, carbon dioxide, copper oxide. Then now conducting the activity. So taking beakers filled with acid, filled with lime water. So individually you can take a beaker, fill it with first acid, suppose HCl is taken. Next, adding copper oxide, CuO. Then observe what happened. Find the nature also. It give you neutral substance or any other. So common products, what you can write? Commonly, what you can write? Products are salt and water here. Salt and water here, right? Then take a beaker, add water, add quicklime. So it gives you lime water, CaOH2. CaOH2. Then blow the carbon dioxide. No need to collect the gas. Blowing carbon dioxide liberation. So blowing the carbon dioxide into the lime water gives you products already written in the activity number 3. Sorry, activity number 4. Right? So metal carbonate or metal hydrogen carbonate with an acid. So in that reaction. So now here blowing certain amount of carbon dioxide, not excess amount, certain amount will give you salt, calcium carbonate, and also forms water here, H2O. This is right. So now we can generalize the equation here. HCl reaction with the metal oxide CuO producing salt and water. Then next, here lime water is used as base. Lime water is used as base. Then adding acid. So is an acid, non-metal oxide, that is CO2, carbon dioxide, producing salt, calcium carbonate, and water. Right? Precipitate forms. So these are the observations. So here in your textbook, in the question, they are asked to give some examples. So what are the examples here? That examples here simply formation of salt and water. That I obtained. Formation of salt and water that I obtained. So simply here the observations from the acid reaction with the base or base reaction with the acid giving you salt and water formation. So this is generalized reaction. As example, right, to write many reactions or to identify the type of reactions here, acid with the metal oxide or metal with bases with the non-metal oxides. I am giving you examples here, HCl plus MgO. So here observe the reaction. Simply looking like what? Acid, metal oxides. What are the products here? You can write down. The next, calcium hydroxide is taken. So for that, instead of it is already given as example to you. So one more example I will give you. HCl with PbO, lead oxide, metal oxide. What are the products? You can predict. Then one more example I am giving you here. NaOH, base, and a non-metal oxide, CO2. what are the products? So these are given as examples to practice this activity. Practice this activity. So I think this is clear to you. Then I'm going to the next topic here. That is simply the activity is observing the ions. Observing the ions that are produced by the acids, bases. Acids, bases. So what about the neutrals? What about the neutrals? So that neutrals we are taking here simply other than salt. Okay. Then here simply acids and bases conducts electricity. So simply electrical conductivity of acids and the bases we are observing. Electrical conductivity of acids and the bases we are observing here. So for that, just you need few materials. So we are decided our aim, what is to understand about the electrical conductivity. To observe the electrical conductivity of acids and bases. For them, you require few materials. What the materials are here? Electrical conductivity. So you need battery and electrodes, then connecting wires, bulb. So simple electric circuit we have to make. So as electrodes, you can use iron nails, right? Pins. What is available with you, that you can use it as simple. As an acid, use a tamarind, tartaric acid, lemon, citric acid that are available. Ice base, soap water, use detergent soap solution. Okay, so here simply according to our textbook, I am collecting the required materials: glucose, alcohol, hydrochloric acid, sulfuric acid, sodium hydroxide. If you want to take some more, you can take it. Then here direct current, that what the current we are using, AC plug, AC current. So 230 volts, AC plug. Then electrodes and wires. So these are the materials required. So here bulb we are using. So here we have to observe the bulb is glowing or not. Then especially you are focusing on the ions. So here compulsory you have to take electrically insulator. Liquid medium is electrically insulator. That is distilled water here. Distilled water, etc. So these are the materials are needed. We are using, these are the materials. So here simply we have to start our procedure. How do we? For that, I'm taking a transparent glass beaker, or you can use plastic mug also. Okay, glass beakers not available with us. You can use plastic mug, no problem. Then in this, just you have to place electrodes. You can use iron rods or iron nails as your electrodes. So with the help of a support, you can place it bottom. So in your textbook suggested to make 2 holes. Then place the pins. Okay, then connect the wires. So directly I am connecting here electrodes with the help of wires. So making electric circuit, connecting the wires to the electrodes. Then connect one end of the electrode with the black wire. Then connect it to the AC plug here. Connect the end to the AC plug. Then red color end I am connecting to the bulb here. The next from the AC plug, other end, right? So one more white piece you can take, other end of the bulb will be connected to the AC plug here directly. So this is your circuit. When you switch on, will the bulb glow? No, because there is no connection between the electrodes. There is no contact between electrodes. So when you switch on, the bulb will not glow because it is work like open circuit. It is work like open circuit. So open circuit, okay. Then just you have to connect that electrodes using a liquid solution. So maybe glucose or maybe alcohol, hydrochloric acid, sulfuric acid, sodium hydroxide. So each time you can arrange this one. Each time fresh dried beaker, not wet one, completely dried. Rinse it. If you use only one thing, rinse it several times using distilled water to make it an electrical insulator, right? So here no ions. Okay, suppose first I am going to fill it with the solution, right? So here simply these two bars, black colored bars are what? Electrodes. These black colored bars are what? Electrodes. Now I am filling this with distilled water now. So fill it with the distilled water. Okay, filled. Then what to do? What to do? Switch on. Will the bulb glow or not? So previously I said to switch on, but empty beaker. Bulb blown or not? Noticed. So empty beaker and there is no direct connection between the electrodes. So bulb doesn't glow. Then now here I filled that beaker with the distilled water only. Only distilled water. Then what happens? Switch on the AC plug. Will the bulb glow or not? Observe and note down. So we know distilled water, insulator, no ions produced, so will not glow. It will not glow. Then remove that water from the beaker. Now add one of the sample solution, what we are taken, right? So here I am adding dilute HCl into the beaker now. Into the beaker, I am adding dilute HCl. Dilute HCl is added. Then electrodes placed in that. Again, switch on. What happens when you switch on? See here, bulb blown. Previously, bulb doesn't glow. Now the bulb glown. When you switch on, bulb blown. So we noticed distilled water does not conducting the electricity. Dilute HCl conducting the electricity. Distilled water, insulator does not conducting the electricity. Now that distilled water replaced by dilute HCl. Okay, distilled water replacing, right? Instead of that, we are taking dilute HCl. Then notice the bulb blown. Then now changing this one. Remove that solution. Add glucose solution into that now. Add glucose solution. Then observe what happens when you switch on AC plug. Here we are noticing that glucose conduct the electricity or not. Switch on the AC plug. Bulb doesn't glow. Switch on the AC plug. Bulb doesn't glow. Then now replace that solution using another solution sample, alcohol now. So add alcohol into the beaker. Same. Switch on the AC plug. Observe the bulb is glowing or not. Bulb is glowing or not. Bulb doesn't glow. Again we are noticing bulb doesn't glow. The next, replacing that with NaOH solution. NaOH solution. So now switch on, bulb glow on. Look at that difference. So I noticed here alcohol doesn't glow, right? Do not glow the bulb. Alcohol doesn't glow on, so do not glow on the bulb. Hydrochloric acid, glow on. So sulfuric acid, if you take, it is also glowing. Sodium hydroxide, glowing. So finally, what we can derive the conclusion from this activity? Here, simply that bulb glowing or not, bulb glowing depends on what? Depends on solution you are taken. Solution you are taken. So what the solutions you are taken? Glucose, alcohol, hydrochloric acid, sulfuric acid, sodium hydroxide. So here simply that solution must act like conductor, because here there is no direct connection between the electrodes. They are connected with the help of a medium. That medium is what here? Liquid solution. That medium is what here? A liquid solution. So that medium only making the bulb to glow here. So that medium we can call it as electrical conductor if the bulb glow. Otherwise, it is said to be insulator. So whatever it may be, bulb glowing or not by a solution depends on ions produced in it. As we learned that concept in 8th class. Electrical conductivity of liquids depends on the ions produced in the liquid solution or liquid. If the solution or liquid able to produce ions, then automatically the bulb glows, because electrodes directly connected or not. Clearly you have to notice no connection directly between the electrodes. That electrodes are come in contact with the help of liquid indirectly. Okay, so simply that electrodes come in contact with the help of the solution if it is acting like a conductor. Which one? Solution, right? So solutions are here insulators and conductors. So here simply from your materials which are acting as conductors here, acids and bases, but not this alcohol and glucose. Suppose alcohol, CH3OH, methyl alcohol, or C2H5OH, ethyl alcohol. Are they conducting electricity? No, not conducting. They are not conducting. So here simply they contain hydrogen. They contain hydrogen. I is like your HCl. HCl is containing hydrogen. But the difference is what? They are not glowing the bulb because they are not able to produce ions. HCl is able to produce ions. So for that purpose, we are taken glucose and alcohol. It is given as a question in your improve your learning. Glucose and alcohol contain hydrogen but not glowing the bulb. What could be the reason? So here they won't produce ions in the water. So that solution substances, maybe acids or bases, they can produce the ions in water. So that can be clarified by the activity number 8 here. So in the activity number 8, you are going to learn about acids produce ions only in aqueous solution or every time. That we can get difference. Do they produce ions only in the presence of acidic solution? Only in the presence of aqueous water, or every time in dried condition? So that we are going to learn in our next class. Tomorrow, that class will be start at 6:45 a.m. So thank you for joining in the live. We'll meet